All right, hello everyone. Thank you for taking the time to wait in line to come in here. I really appreciate it. Hopefully I'll be able to convey some educational information over the next little while. We'll all learn something together. We're talking about a really exciting space. We're talking about securing serverless applications. But first, unfortunately, I have to do a tiny bit of housekeeping. This is a sponsored session. It's sponsored by Trend Micro. I work there. I'm the Vice President of Cloud Research. We focus on EC2 and ECS security today. You may or may not know it. You probably are sitting on a ticket. That ticket, if you bring it to the booth, the Trend Micro booth, it's a big spaceship you can see with the mobile above it of the universe. We're giving away a Nintendo Switch once an hour. So worth your time to go check it out. If you haven't already played Super Mario Odyssey, you absolutely should. It's probably the best Mario game out there. And you could play it on a brand new Switch that you'd have a chance to win if you visit the booth. So that out of the way, we are going to talk about serverless security. It is an interesting challenge because I find it changes, or at least it pushes back on everything that we assume to be true about security. So how the next hour is going to break down really comes into four areas. We're going to actually define security. I'm sorry about that. I apologize in advance, but I think it's important. Normally at a 300 level talk, we kind of assume we all know what we're talking about, though I will guess that a lot of you have heard various definitions of serverless over the last couple days. It seems to be our favorite activity within the serverless community is to debate exactly what the term means, but we're not going to do that. We're actually going to debate something far more fundamental. We're going to debate the definition of security itself, because I think it's absolutely critical that we understand what we're trying to achieve when we talk about security. We're going to look at a sample architecture, and we're going to use that to frame around the rest of the talk, because this is a very practical talk. It's a very applied talk. We're going to go through the steps that you need to take to secure a serverless application as it stands today. Right? So we're going to use a sample application, but then you can take these same steps and apply them to your application. So that's the goal, to have a takeaway, to have a series of steps that you can apply to ensure that you're doing your best for securing your application in this new design paradigm. That'll come away as a strategy, nice and easy. It all fits onto one handy little slide. It's sort of like the money slide. It'll fire it out on Twitter afterwards. Hopefully you guys agree and take that as the takeaway. So let's go down to the basics, the absolute basics here. Security defined. It turns out it's actually really easy to define information security as a concept. Of course, easy at the start, and then when we start to look at the details, it gets really, really tricky. But it's a simple definition, right? It's the practice of preventing unauthorized access and use of information. Like all definitions, that is dry and boring. It's difficult to kind of wrap your head around somewhat, but it really boils down to, it's our data. We want to make sure that we know who's accessing it or doing something with it, deleting it, copying it, moving it around. Anything to do with that data, we want to make sure that we're controlling that access and are aware of that access. That makes sense for everybody. Yeah, I also am very interactive, and I don't take no for an answer. Yes. Thank you very much. This is good. We all got lunch. That's a good thing, right? You can tell when you do these talks early in the morning, everyone's kind of hiding behind their coffee, mumbling. That's exactly. So we're all agreed on this. This is good. So this actually leads to a tendency within our organizations to set things up in a very specific way. And I will take the heat from this, but I will tell you that I don't agree with how we set up security in our organizations today. I think we actually set it up for failure instead of success. And that comes down to what we're talking about here, which is a lack of understanding of what we're trying to accomplish. So I think we can do better. We're building on cutting-edge designs in a cutting-edge cloud. I think we can do a lot better than the standard. But really, when you start to think about security as this, trying to control access to your information, you start to think about your security team. What do? Right? Our security team, they're going to stop hackers and prevent breaches. Right? Does anyone have a different idea of what their security team does? Or this is at least aspirational, if not practical? Right? You're hoping this is what they do. This is how most organizations conceive of a security team. We have this team of experts. They know their stuff. They work to stop hackers and breaches. Not really true. It is part of their job, absolutely. But that is not the only thing you need to focus on. And if this is all you're focusing on in your security is stopping hackers and stopping breaches, you are putting yourself at a disadvantage, a competitive one. You are putting yourself as a defensive disadvantage. You are leaving yourself far more vulnerable and accepting far more risk than you actually realize. Because at the end of the day, security is everybody's responsibility. That's my dramatic pause. It is everybody's responsibility. Okay? Can we just repeat that just so we all internalize that? Security is everybody's responsibility. Okay. Yes, exactly. See something, say something, especially if you see a penguin in Hawaiian shorts. That is definitely reportable. But security is everybody's responsibility. And that campaign of see something, say something is an excellent example of trying in a common scenario to try to distribute the challenge of securing, in this case, society, but security has impacts everywhere. If you're in an organization making information, creating information, when you create that information, you are in the best position to evaluate the risk to it and to determine that, to share that out with the rest of your organization, right? If you're writing a Word document, unfortunately, and it contains sensitive information, you know that at the start, right? Or it could be just the lunch menu and it's not sensitive. But it is everybody's responsibility, from the office manager all the way to the CEO. Everybody has a role to play here. And that leads us to a second, more refined definition of the goal of security within IT, within solution delivery. It's very simple. You need to ensure that your solution does what you built it for. Right? Does what you built it to do. So works as intended and only as intended. And that's the kicker. That's the catch there. Right? You build this application, you sit there, you go, great, okay, I'm going to make TPS reports. Right? And as a developer, if you get a TPS report at the end of your execution, you're like, great, I did my job, it works. From a security point of view, from the paranoid tinfoil hat point of view, I sit there and go, well, okay, it makes TPS reports. Can I ask it to fire out different kinds of reports? Can I get it to dump more data than you intended? A developer would look at it, and I don't mean this in any disparaging way, though I'm sure I'm going to get talked to in the hallway from all y'all. But as a developer, you sit there and go, I finished my assignment. I'm done for my task for this sprint. It makes a report. I guarantee the bad guys out there, the cyber criminals, the malicious hackers, they are looking at that and going, great. You didn't bother to close off and sanitize your input. I can ask for anything I want out of your data system, and you provided a nice avenue for you. So the key here, ensure your solution does what you intended it to do, and only that. That make sense? I'm assuming so. No one's thrown anything at me yet, so this is good. Right? So we're on the same page here. We're understanding what security means. And this boils down to, in the AWS cloud, it boils down to the shared responsibility model. Now, you guys over the last few years have been beat over the head with this, but it is a good thing. It is a fundamental understanding of how we balance security between us and our cloud service provider, AWS. So we know we are not dealing with any on-premise scenario in the serverless world, right? That's not where we're at. We're not dealing with any infrastructure as a service. We're also not dealing with any platform as a service, right? And we're living in the SaaS world, right? Or more appropriately now, they're trying to shift to abstract as a classification of service. This is where we live. We have delegated the security of everything from the app down to the physical layer to our service provider, to AWS. And that is a great thing for us. It's less work that we need to do. And I'm pretty sure if I asked you guys who in here would like to do more work than necessary, I would get nobody, right? Maybe one or two who are crazy, but still, nobody wants to do more work than they need to. And this is why we're pushing serverless designs, right? We're delegating more and more out to our cloud service provider because it's not an advantage for us. We are trying to make an application that serves a purpose. That purpose is not to maintain itself or to patch Windows better or to deploy containers better. It's to focus on delivering our business value, right? So we live in the SaaS world. And that means that when it comes to serverless security, we really have three components that we need to focus on. Okay? We focus on services. So which services are we selecting to build into our application? We need to make smart choices about those services. They need to meet not only our application needs, but also our security needs. Right? If we're dealing with health information, are we picking a service that is classified to store health information? Okay? If we're doing user authentication, are we picking something that meets our needs not only from an application perspective, but also from that security concern? The second area we need to look at is our code. Traditionally a problem, continuing to be a problem, will always be a problem. But it's something we need to pay a special attention to because our code is now executing in ways that we never really drove on-premise, right? We're going to purely event-driven architectures. It's scaling out without our awareness. It's a wonderful thing. However, there are some concerns there. And then we need to map out our data flow. We need to really understand how data is flowing between these services that we don't control. You need to know where things are going. That's really, really critical. Okay, so that's how security is working. We know this understanding. Our goal from a security perspective is to make sure that whatever we're building does what we want it to do, but only that. The way we do that is understanding we're working in the shared responsibility model. We're working purely in SaaS services when it comes to serverless designs. And so we're looking at these 3 areas. Okay? That's our foundation. That's what we're going to work on from here. So we have an application. We're going to use a fun application. This is an AWS application. Is everyone familiar with Wild Rides? A couple people? That's good. I wish it was a real company. It would be amazing. Unfortunately, it's not. It's one of 2 AWS sample applications. They are available up on GitHub. The Wild Rides, the other one is a zombie apocalypse application. Wild Rides, as you could probably guess from the absolutely insane hero graphic from their website, is a fictitious company that books rides on unicorns. So if you want to ride on a unicorn, you go to their website, you coordinate, you fill in the schedule, you book a ride, and you could be, I guess, Professor Wolf riding in the bottom corner, but that's the whole goal of this company, is that you can book rides on a unicorn. The code for the entire application is available on the AWS Labs GitHub site. That is a fantastic GitHub organization, by the way, not just for serverless solutions, but a ton of other stuff. They really sneakily just kind of create new repos with all sorts of amazing tools and nice little hacks and connections between services at the Labs thing. But AWS Labs / serverless workshops has both the zombie and the wild ride application. But if we look at it from an architecture perspective, we've done a little bit of a modification, but you can get this conceptually. Very simple design, right? But it's going to serve our purposes today because we're going to walk through this design and we're going to see how we're going to apply step by step our security principles to ensure that this thing does only what we want it to do. Okay? So we start very simply, users, right? We always have users. They're coming in, they're interacting with services like Route 53 to get the addressing information. They're going through CloudFront because we like our distributed edge locations around the world and our service performance optimization. But we've integrated Amazon Cognito. So we're using Cognito for our user pools. We're using S3 to deliver the vast majority of content. In our case, we are lovingly using a publicly readable bucket because that's our intention. We are not falling into the recent traps of, oops, I'm sorry, that was public, and I explicitly turned it public, but we will cover that, don't worry. And then our more complicated code is running behind API Gateway, running Amazon Lambda, and into DynamoDB. As of this morning, we could have also swapped out Aurora in here, because Aurora now has a serverless implementation, which is really, really cool. So that's our design. Step 1 is an absolutely critical step, and it absolutely baffles me how many people don't stop and do this one step. So if you can do me a favor, if you take away only one thing from this talk, please, it is this. Step 1 is to map out the data that is involved in your application. To explicitly sit down as a team and look at the types of data that you are dealing with in this solution so that you understand your potential risk. Sounds ridiculously simple, and it is ridiculously simple, but it is insanely valuable. So for us, booking rides on unicorns, as fun as this is, we have personally identifiable information. I, Mark, am going to book a ride. I need to create an account. I need to give them my address, my name, contact information. So I have personally identifiable information in this application. We have user information that we need to protect. That is important. Depending on your jurisdiction, that is regulated by law. Right? If you have dealt with some security compliance things at all, you probably heard of the looming GDPR. This is a European Union regulation that applies to anyone who is handling EU citizen data. Anyone. Okay? And there's very strict requirements around how you handle personally identifiable information, besides being just the good thing to do. You don't want to expose user information unnecessarily. Users trust you with that information. You need to maintain that trust. Second type of data we've got in our application is the scheduling. Right? So we have users requesting rides on our unicorns. We have to keep a schedule of those unicorn availability in line when they're booked, when they're available, that kind of stuff. So not as sensitive, but still there. We also are processing financial, right? We're not giving away unicorn rides for free. We're in a business. We're charging for our unicorn rides, right? Some exceptions for kids, but in general, we're charging. This would be an insanely profitable business, right? I mean, come on. So we've got financials. We're processing credit card information. There's sensitivity there. We have mythical creature identifiable information. These are not cheap assets for our business, right? Unicorns are expensive. We want to make sure that we protect that information, okay? And you can sub in for your business whatever your core intellectual property is, right? Hopefully it's unicorns, because that's just awesome. But we need to protect this information. And again, we also have code. Our code reveals our business processes, which could be sensitive, right? It depends. In this case, it's not super sensitive because the code's not really complicated. We're essentially matching one thing to another and making sure that we're taking payment for that. But your applications are going to be far more complex, and that code could be quite sensitive. So this is the data that is involved in our application. This is good. With step one, we know what kind of data we have. But now we need to take it a step further, no pun intended. We need to look at the value of that data. And we've already started to touch on this, but we should have some sort of ranking system. And I will tell you right now, there are a number of formalized systems for ranking value of data and risk appetite against those data, against that data. At the end of the day, they're all completely made up, pull a number out of you-know-where. But the important thing is that relative to other components of data within your system, that number or that ranking means something. So I've used stars here. I could have easily used ice cream cones. I could have assigned a number. I could have done whatever I want. The important thing here is I'm prioritizing my data based on the risk that I, as a business owner, am willing to assume. So I've got 3 stars under my personally identifiable info, 3 stars under my mythical creature info, because that's my most sensitive information. Okay? Again, very simple activity, but very, very valuable, because now we have a metric, a rubric to make decisions against. So if we need to make a trade-off, and normally security, like operations, like design, is some sort of trade-off, now we have a way to evaluate that trade-off. So if I have to expose some data within my application, I'm going to expose the scheduling data, because it's not nearly as important for me. Right? So that's step 2. We've classified our data in step 1, or we've listed our data in step 1. In step 2 now, we're classifying that data. We're evaluating our basic risk appetite there. So now we start to dive into our services themselves. So we know what data we have. We know how sensitive that data is. So now we're going to take this architecture, the same thing you saw before, and we're going to go through each of these services to see how we can configure them and what we can do for our data within those services. So our step 3, what are the services that touch each piece of this data, each piece of data? Right? We know what data, where is that data going? So we look at something simple like Route 53. That's our DNS information. The only data that's intended to be in there for us as our application in Wild Rides is simply infrastructure. It's just the DNS records. It's not sensitive. There's very low risk for us there. Right? That makes sense? Yeah? Good? Okay. CloudFront. I think this is interesting. This is the reason why we go through this exercise. When it comes to CloudFront, right, this is our content delivery network. It has the potential to cache information. Our intention is only to have our website code in there. So HTML, JavaScript, CSS, right? It has the potential, however, to also store our sensitive data if we mess up in our code. If we make a misconfiguration, if we make a mistake in our application code, we could theoretically have that information sitting in CloudFront, because that's our primary way of delivering information back out to our users. So we need to be aware of that. There's a difference here between our intention and the possibility. So we need to put some mitigations and some controls in place to ensure that that doesn't happen. Similarly, we go down and we look at Cognito. Cognito is purely designed around personal information, so we know it's going to store personal information. It has really no other possibility to store other data within it, so it's just straight PII. It is a high-risk item for us. We look at S3. Again, S3 lines up exactly with CloudFront for our application, where our intention is to have HTML, JavaScript, and style sheets. However, we have the potential, if we miswrite data in there, because we update our code for our application as we process things, we have the potential of writing the wrong information in there. So there's a risk. It's not a big risk, but there's a risk. Again, you just need to be aware of these things. They're not bad, they're not good, but if you don't look at them, you could end up shooting yourself in the foot. Generally considered a bad thing. So we look at the last three, we have the exact same layout because it's the exact same line of code. It's the exact same branch of our application. We've got our personally identifiable info for ourselves, for our unicorns. We've got our scheduling info, our financials, our code. These three services touch everything. So the interesting thing is, while we have a variety of services, we have almost a uniform risk across all of them because all of them have the potential of handling our sensitive data. So now where you might have not put too much attention into the configuration of CloudFront, now you realize that there's a potential issue there that you need to put mitigations and testing and compensating controls in place for. Okay? This is why we go through these steps. This is our third step. We've gone through two basic steps. This one's pretty straightforward as well. But now we're getting a better awareness of what potentially could go wrong. We know we're processing financial information, so our next step is going to be verifying compliance eligibility. That's a super exciting and fun phrase to say. Basically sums up the entirety of compliance. If you can stay awake throughout it, it is a great exercise. It is challenging. However, it is very important because we are processing credit card information in our application, right? Our unicorn rides aren't free. So what we're doing is we're falling under PCI compliance. PCI is the payment card industry standard for information security. AWS has a list of compliance attestations on their website. They also have a service, and I use quotes around service because it's essentially a landing page called Artifact. It's great that it's a page because you used to have to submit a support ticket. Now through Artifact, you can simply click on the button and get AWS's copy of their PCI compliance report because you need that as part of your compliance report, right? So in PCI, there's a concept of an ATO, which is authority to operate. And in each of these services that we are using has an authority to operate. So they've been certified to handle PCI data. This is good for us. If we were dealing with a service that wasn't certified, we wouldn't be able to use it and still maintain our PCI certification, which means we could face possible fines and possible legal action for processing credit card information in an uncertified way. Again, super boring, but also really important, right? And sometimes you got to churn through the boring stuff to get the good stuff. But all of our services are in scope, which is great. However, it's not that simple, because it should be that simple, but it never is. There is an older white paper. It's about to be updated, thankfully, but this is the Overview of Security Processes white paper from AWS. It lists out how they generally approach security, the processes that they take on their side to secure the availability zones, the regions, how they vet personnel, all this type of information, and it basically lays out their principles for security. You heard some of it last night at Tuesday Night Live with Stephen Schmidt when he was doing his about 5 or 6 minute amazing talk about automating security. It's laid out in here. There's also a section in this document for each of the services to call out the differences for each of the services. So they'll give you the generic approach, and then they'll say for Amazon S3, here's also what we do. Here are also additional concerns that you need to be aware of. And what you'll find out is that our previous slide was actually insufficient scope for our compliance. So we know we fall under PCI compliance. Our last one, we actually missed 2 services that are in scope because they are supporting services for our application. In this case, it's Identity and Access Management, so IAM, and KMS. So we're using some encryption keys, and we're having the key management service use them for us. But now, by going through this process, we've seen that we actually have a couple extra services that we didn't account for. Right? This gets a little bit more complicated. On the bright side, they're core foundational services from AWS, so they have pretty much every compliance attestation you can think of, but you still need to double check because you have to be able to prove it. And the goal here, the goal of this exercise, of this area of the exercise, is before you start building to check this stuff out. Your worst case scenario, if you ignored this, is you build a solution, you're ready to roll, and then you realize you're using a service that's not compliant. And now you go to your CEO and you say, okay, well, we have a risk here. We can roll it out and face potential fines and lawsuits, or I can, pack my bags and I'm gone, in worst case scenario, or you re-architect your application. Right? It's far easier to go through this utterly boring, sleep-inducing process ahead of time to ensure that you don't end up in that position, right? Okay, you're still awake. This is a positive thing. I've been speaking publicly for quite a while. I have yet to find an exciting way to talk about compliance. So I appreciate your patience and hanging in there. It is absolutely critically important. So our next step, step 5. We have these services. We know we can use these services. Let's get in and start doing something with these services. First thing we need to do is read up on them. You need to know what levers you have. We are dealing fully with abstract with SaaS level services, which means we don't have access to install software in the service itself. We are reliant on AWS to give us configuration options. So I'll come back to our S3 example. There has been a non-stop stream of mainstream headlines of various companies being breached on data in S3. So I'm going to just double check because I want to give you guys a little exercise. Hands up if you use S3 in a serverless design today. Right? This should be 100% people. Come on. But, a little exercise, that's good. Tricked you into that. So with S3, you should be aware, but just to reiterate, when you create a bucket in S3, by default, it is secure and locked down, and the only person who can access it is the entity that created it. There are ways to override that and set global policy and things like that, but those are explicit actions that you have taken as a user. So if you open up a new AWS account today and you create a bucket, whoever created that bucket is the only person that can read that bucket and the things in that bucket. You have to take explicit steps to open it up public. Because of the rash of misconfigurations, because people didn't do that, AWS has taken further steps. So when you create a bucket and turn it public, within the management console, if you're still using the management console for stuff, there's a big giant warning now that says, this bucket is public. Are you really sure you want to be doing that? And you can click yes, and then it still warns you again. It says, well, this bucket was public. After the last rash of exposed data in S3, AWS actually sent emails to people who had public buckets and said, are you sure you want this bucket to be public? Now, the vast majority of those are just static websites, which you want to be public. But I'm sure quite a few people woke up and went, oh, crap, that's public? That shouldn't be, right? Because we saw examples of high-level government agencies. The latest one was actually an intelligence agency that made this mistake, right? But we're human. We make mistakes. If you go through the process, though, and configure each service appropriately, you'll reduce the likelihood of ending up on the front page, right? Because can you imagine that conversation when your CEO comes down and says, so, we were in the New York Times today and I didn't like the article. Can you walk me through what happened? And you say, with all honesty, well, I took something that was completely locked down by default and then I turned it publicly readable so anybody could take a look at whatever they wanted. That is not a conversation that will end well, right? If it ends up differently, call me because I'd love to hear the story of how you backtrack out of that one. So we need to know how to configure these services appropriately. IAM is another example, right? So IAM, by default, everything's deny, right? You can tell why security folks seem really happy, right? Everything's deny, no to everything. But that's how you want. You want to start from a position of security, right? You want to start from a strength position and have everything secure by default. And then using IAM, you can assign permissions and assign privileges to allow certain actions to take place. But you need to know how that works. You need to read up on the docs, and you need to understand which widgets we can adjust. That leads to the second part of this piece. So step 6 is actually setting up tests and verifying that what you thought you just did in configuration continues to be true. Because if we go back to that S3 example, those buckets, all of them, probably weren't public from the start and go. At some point, somebody probably made a simple mistake, and they sent the wrong parameter in the API call, right? Or they clicked the wrong button in the management console, and they flipped it public. You need to continue to test that what you set up is actually what's running in production. The beauty is, you guys all know how to use AWS Lambda, right? I think that's a pretty safe bet in this crowd. We're comfortable with AWS Lambda. We're comfortable with CloudWatch. We can set things up to automatically test this for us. So we need to test our assumptions and continue to test them constantly, right? Any change that happens within your production, you should rerun all these tests. It costs you nothing to do so, or at least pennies on the dollar. Why wouldn't you verify? Okay, that's services. Nice and easy. We understand services. So let's tackle code. Everyone's favorite subject, right? We all write great code, right? No bugs? Nice. I got literally a thumbs up from Jeff in the front. Nice. Yes, we do make mistakes, though some of us less mistakes than others. We do. But code quality is a problem, right? We can all admit that. We're mature adults. We can say that code quality is an issue. I would counter that and say that code quality is actually the problem that we're dealing with. And it's not a new problem. Okay, so you don't have to feel bad. But security vulnerabilities start somewhere, and unfortunately, look in the mirror, they start with us, right? We write the code that has a vulnerability. May not be you today, but it will be you at some point. So the goal for us is to figure out systems that help us to prevent writing these types of issues. But if you are at all doubtful that code quality is a problem, let me walk you through something that is both hilarious and terrifying at the same time. Are we all familiar with the OWASP top 10? Enough? That's an amazing actual response. A lot of people are. So for, it was about 60% of the room was nodding, hopefully not nodding off, but nodding in some form of a positive acknowledgement. For those that aren't, the OWASP top 10 has been, since 2010, a list of application security issues, ranked by how common they are. This was the list in 2010. So you can see some pretty understandable issues. Injection. So at that point, it was primarily SQL injection. You see the XKCD comic. I'm always one of my favorite of little Bobby tables, right? And you always, the perennial example for code injection, when you're going to a text input box and you write whatever you want, and then colon equals 1, and you're trying to complete an SQL statement in order to get the database to spit back more information than it should, because that comes back to our security principle, right? Somebody who wrote that code said, hey, when I fire off this query, someone inputs text in a text box, fire off a query, it returns my results, I'm done. Bad hacker comes by and says, what else can I type in there? Right? I can type another part of an SQL query or bridge a query and get information back. So injection, very straightforward. Cross-site scripting, all this stuff is really straightforward. There's some interesting ones as far as failure to restrict URL access. You got to remember it was 2010. Unvalidated redirects, things like that, but all sort of common 101 security problems when it comes to web application, right? Nobody's shocked by this list. Nobody's like, oh, I never heard of that. It would be nice if we had never heard of this, if these were never issues, but unfortunately they are. If we fast forward 3 years and go to 2013, this is the delta in the list. They did an update on the list, and you'll see there's not much different. Things move around a little bit, so up and down a tiny bit. But we get 3 new areas, but they're actually just sort of compilations of older ones. So we get sensitive data exposure, which is really a generic term for so whatever didn't fit in the other 9 categories. We get missing function level access control, which is a pipe dream that we never really got until now. And then using components with known vulnerabilities. That's my absolute favorite, right? That's like going outside in the rain with an umbrella with holes in it. And you're like, why am I getting wet? I don't know, right? So known vulnerabilities, that one came in at 9, so at least it was only 9. Then this year, we just did finished an update. It's just about, it either has just finished RC2 and has gone gold or still sitting in RC2. Back to some old favorites. Broken access control, insufficient attack protection is the new phrase of we couldn't put this in the other 9 buckets. So we changed the wording a little this year. And back to a new one, an actual honest new one, which is underprotected APIs. But look at the difference over the last 7 years. There is almost no change in the vulnerabilities that we are dealing with in our code. Think about what didn't exist, like this conference 7 years ago. Think about the state of the AWS cloud 7 years ago. We've done really good at building new technology. We're still making the same mistakes, right? So we can do better. The good news is we can do way, way better, but code is still a major problem. So step 7, write better code. I'm gonna just hide now. Yeah, exactly, we're done. It's a, thank you, good night, we're finished. Seriously though, try, at least try to write better code. This is something that we all should aspire to. And this comes back to a whole number of things, but treating code, treating writing software as a craft, as a profession, trying to get better at it, right? We're all under an insane amount of pressure to deliver things faster, but at the end of the day, we do need to write better code. So step 7, aspire. You can laugh for sure. Somebody could write better code at scaling up emojis instead of pixelating, actually scale them up to vector. But we need to do better. So this next one, when it comes to code, is reducing and verifying your dependencies. So this comes back to the OWASP top 10 of deploying code that has known vulnerabilities. Do I need to go into the left pad issue? No, this is my litmus test for Node developers. Thankfully, there's not. OK, so how many folks developed their serverless app in Node as the primary language? OK, this is a positive development for the community. Because if I asked that a year ago, everyone's hand put up. So for Node folks, you can just tune out for a second. It's not necessarily bad. Yeah, I'm totally going to get beat up in the parking lot, aren't I? OK, for those of you that aren't Node developers, left pad was an issue that happened when, for some reason, developers who were building in Node.js didn't want to write a function to left pad their own strings. So they used a module from NPM, from the package manager, to do it themselves, for them. I don't know. I don't understand, but it's what happened. And there was a kerfuffle. There was a whole thing with the developer who maintained that package. And all of a sudden, that package was no longer available. And a ridiculous amount of Node apps crashed. They failed to deploy. They failed to update because the package they were relying on to do something as simple as left pad their strings was no longer available to them, right? Not too many long-lasting ramifications other than kind of making Node the butt of a few jokes for a while, came from that. But it does illustrate a very real issue. And that issue is when you pull in a dependency into your code, you are now responsible for that code, even if you didn't write it, because it's part of the application you're delivering. And I'm going to show you, hopefully this will work. This is a visualization of some popular packages. This is React. So when you import React, every node on this graph, which could be a Neptune now, is another dependency, right? So there's 17 additional dependencies from one import. This is request, so popular HTTP handler. This one's going to pull in more, right? Look at how many dependencies are pulled in with one import statement. There's 53 downstream packages. Browserify for simulating browser events. A little less popular, but a ridiculous amount of complexity in this. So you remember, when you type one line of code to require this package, this is what's actually being imported into your application. If there is an issue with any one of these dots, it's on you. Right? This is not even the worst. I didn't cherry pick these. I just picked things that were common. 132 dependencies. Gulp. This should never end up in production, yet it does. It's a build chain library. Yet a ton of people just deploy it out to production on its own. This is just going to go for a little while. This just keeps going, right? It's insane. But again, the beauty of this, and as a developer, this is great. We're reusing code. We're helping each other out. One line in my Node.js app imports 181 different dependencies written by different people under different coding standards, different level of competency. Can you guarantee me that all of those are safe, that none of them have known vulnerabilities? Right? This is where vulnerability management comes into play. This is where GitHub just released a phenomenal new feature that actually highlights within the repo UI known issues downstream. It's not perfect, but it helps out. But this is the disadvantage of importing other people's code into your application. There's a huge upside. You didn't have to write all this stuff. But the absurd example of left pad, right? We're talking 2 lines of code in most languages to do left padding, if not default built in, to the extreme example of deploying insanely complex networks of code within our application. We are responsible for them. You need to you need to cover off these dependencies. So this is a real issue, right? And it's not just Node. I do like to beat up on Node, but it's not just Node. It's the same issue in Python. It's the same issue in Go. It's the same issue in Java. It's the same issue in C#. Pick your language. It's an issue. So what we need to do to help cover this off is test even more. We need to write better code. We need to look at our dependencies. We need to test. And I promise I'm not a test engineer. But we need to test, OK? You need to write automated tests. The beauty is you need to be running these tests constantly. And that leads to the next one, far more specific to security, is static analysis. Okay, so static analysis is a concept of running an analyzer against your code to look for known issues. So the easy example is something like a buffer overrun, right? Where you're not, we're seeing it less and less, thankfully, but if you're working in C or C++, it's still a real issue, where you're allotting a specific amount of memory and then you're running past that allotment and into other functions, and that can have downstream effects. Excuse me, a static analysis tool can help you find that, right? And there's a phenomenal amount of really high quality static analysis tools out there in the open. These links will go live after the talk. You notice they're all the same. It's 2017, this session code, so SRV308, and then numerically. This one actually links to a GitHub repo that is a list of, by language, freely available open source static analysis tools. And the difference between, let's say, something like a reputational service where there needs to be constant investment, and that's where security companies come into play. When it comes to static analysis, they're looking for foundational structures within the code. The open source alternatives are phenomenal. There are commercial alternatives out there, but you can pretty much cover off all your bases with the open source ones. Pick your language, pick your choice, implement them into your build chain. They are going to help. They're not perfect, especially in a serverless environment. The challenge in a serverless environment is the static analysis is used to kind of rebuilding your code, the entirety of it to map out flow. With a serverless design by default, we have actually broken up that flow. And when you run static analysis against your code, it's getting a far narrower view of what's going on. So it's not going to be as effective if you were running it against something like a monolith, but there's still value in there, especially when it's very easy to wire up and you don't have to worry about it. You just set it up, it's in your automated chain, and it will spit out and tell you results at some point if there's an issue you need to address. But it's yet another step for us to take. So that's step 10, implement in static analysis. Make sense? We're all going to write amazing code now? Yes? There should have at least been some enthusiasm there, guys. Okay. We all will write better code. So that brings us to our third major pillar when it comes to serverless security. This is data flow. And this is really unique to serverless as far as the impact. We have dealt with it within traditional applications, but normally we deal with it just in architecture, and we know that everything's running within the same actual application code base. Now we're taking those same concepts, right? It's the microservices design pattern, taken to the somewhat extreme in that we don't run any of these services. So we need to look and monitor the flow of information. We mapped out the information that we're dealing with early on in our process, right? Step 1 and 2. Now we're looking at the flow as it goes between the services that we've picked. We want to make sure that that information is only going between the services that we want, and that the right information is ending up in the right place. Now, fortunately, there's some tools available from AWS that help with this. They're not perfect, but they do help. The first one I want to talk about is AWS X-Ray. X-Ray, like all AWS services, when it was announced, was okay. It met a very specific use case. In the last year since it was launched, they've added a ton of great functionality. The idea here is to help you analyze and debug distributed applications. Sounds like a serverless design, right? Very, very handy. You end up, once you enable it, you start to get maps like this, okay? You can read it, I think, decently enough. But you'll see they've got different attributes in different places, kicking out to various AWS services on the far side. And this is mapping from CloudTrail data. This is mapping from some other data sources within your AWS account to show you how information and code is flowing within your application. So you can line this up with your expectation with your architecture diagram to ensure that it is actually what you expect. X-Ray provides a whole bunch of performance information and operational metrics behind that as well, which is very handy. You can see where latency issues are, try to troubleshoot it. But from a security aspect, there are very real advantages to this view, because you start to see that, okay, I've got 4 things going into DynamoDB. Well, on my map, I only had 1 service pushing into DynamoDB. Why do I have 4 here? That's a very valid question. It's something you should be asking, right? But you don't have that visibility unless you're using a tool like AWS X-Ray. Okay, is anybody using X-Ray today outside of the basic debugging functions? Are you using it for data mapping like this? No? There you go. So there's a good takeaway. Everybody can fire this up and start to use it, because it is, while it's designed as an application development assist tool, there are the very real security impacts. A little more detail, Amazon CloudWatch. In this case specifically, I want to talk about CloudWatch events. So most of the time when people talk about CloudWatch, they think metrics and alarms. That was the beginning. That was kind of the boring side. It's since expanded to logs. So if you're running EC2 instances or ECS hosts, you can fire up logs and custom application logs to it. For our purposes, we want to use the events functionality. So the events functionality covers a lot of API services from AWS, not all of them. And that's the caveat to know, is that not all API calls in AWS get triggered, will trigger CloudWatch events. So you think CloudTrail is a 2 to 4 minute behind your API call, gets dumped to an S3 bucket, has about 98% coverage of all the API calls for AWS. CloudWatch events is a near real-time trigger of the more common API events, and more are getting added all the time. But it allows us to set up a trigger. So what we're going to do is we're going to start to look at various events that happen to create essentially a whitelist. So we're going to build our own little security control, and I'm going to walk you through that in a couple minutes here so that you understand this is a serverless security control that we're building on top of our serverless application to ensure that it's doing what we expect, right? We're trying to map the data flow. We're trying to look at the access to these services within our design. So we look at CloudWatch events. I would suggest you capture all the CloudWatch events, and we're going to send them to a Lambda. For our serverless design, we know what things should be called, right? So we have a list, a whitelist that we can use of known good transactions. We know what APIs should be called. We're going to create a list. We're going to keep that in an S3 bucket. We're going to have our Lambda function check the incoming event against our known list, right? Is it good? Cool. Done. Very simple concept, right? If it's bad, what we're going to do is we're going to store the fact that that happened. And we're going to have a second function that's going to do some aggregate metrics for us, right? It's going to look and say, okay, was that one of? Was that multiple times was that happening? What is going on here? This is a way for us, very little code, to give us excellent visibility and awareness as to how data is moving throughout our services that are being called, okay? So we have the CloudWatch event fires, our Lambda goes, it looks, see if it's known good against our whitelist. If it is, you don't have to do anything. We know it was good, it was allowed to happen. If it's not, then we're going to do that aggregate, and we can take action from there as well. So a very common action in security is to raise an alert, right? Send an alert to Slack or to whatever you're using to say, hey, there's an additional thing. If we saw back to our X-ray example, there are 3 additional services that are calling Dynamo, right? Or this identity is calling Dynamo, and it shouldn't be in this context. Or it's calling it with different parameters. So you could, of course, use IAM to lock all that down so that it never possibly happens, and you probably should. But realistically, permissions start to get a little bit bigger. People start to allow things to troubleshoot an issue. Maybe somebody was trying out a new feature branch and you weren't aware of it, right? This is an easy way to set up at almost no cost real whitelisting for service calling, okay? And I'll be tweeting a bit more about that, but I've got a blog post coming out that I'll fire out under the reinvent hashtag that explains this process more in depth, because I think it's a really good pattern to set up. It's a very simple pattern to set up, and it gives you a huge advantage, and it complements using X-ray. Next service I wanted to talk about was Amazon Macie. So Amazon Macie launched in the New York Summit in August, and it's targeted initially at S3. So it's a very simple service. You point it at an S3 bucket, and it starts to do its thing. What it's going to do is it's going to analyze CloudTrail data to look for API call anomalies. So now we've got 2 things looking at CloudTrail data. We've got X-ray, we've got Amazon Macie, we're writing our own little whitelist checker as well. We're covering our bases here, right? We're building defense and depth into our serverless application. So with Macie, it's automatically going to look at the basic CloudTrail data, but it's going to take things a step further. It's going to look at configuration. Yes, before you ask, I know you love talking about S3 public buckets. Macie will raise an alert and tell you if you have an S3 public bucket, so it's yet another thing that will tell you not to shoot yourself in the foot. But it also will analyze what's in the keys in your S3 bucket. So it will look into the data files in your bucket to look for sensitive information. It's pre-configured. Last time I checked, it was 786 different risk types and data things. So it's going to look for personally identifiable information like credit card numbers. It's going to look for social security numbers. It's going to look for sensitive information like that, like date of birth, all these types of things, and raise alerts based on that and classify risk automatically to those buckets. It's a really simple service to use because you don't have to do anything beyond turning it on, right? This is where security is moving, especially into the serverless realm, where these are completely automated services that once they're on, they will just be quiet until there's an issue and they'll generate an event. You can capture the Macie event through CloudWatch and then react to it if you want. But it provides you this visibility that we've never seen before, right? You can see in the screenshot, there's a slider for risk. So they use a scale of risk 1 to 10. Again, you could pick any number you want. The Macie team picked 1 through 10, and they're classifying the data that they found within your S3 bucket based on that risk. They again look at user behavioral analytics. So if you have a user who has permission to read your S3 bucket or an application component that has permission to use your S3 bucket, if it's normally pulling out a gig a day and all of a sudden it pulls out a terabyte, Macie will flag it. So Macie will look at allowed actions which at the end of the day, you have allowed actions in your application. That's how your application works. You're allowing different services to do different things. Macy will use machine learning to do behavioral analytics on top of those actions to ensure that if there is an abnormality, that it will raise an alert for you that you can then react to. It's got a really slick UI. Actually, if you guys saw Tuesday Night Live last night, Jenny Brinkley, who hosted the discussion with Greg Peters and Stephen Schmidt, she was the co-founder and the leader on Amazon Macy. Really impressive UI, very, very slick. You can see, boil it down to executive level simple of medium, high, and low. So in this case, we've got a high-risk document on an ACL that enables global access. In this case, I'd actually uploaded an SSH key for an EC2 instance, and the permissions had it set to public, and Macy found it and flagged it and said, you probably don't want to be doing that, right? But again, it's a serverless security tool from AWS. You pay on ingest, so when it does the data analysis, and then there's a small ongoing fee after that, but an insanely powerful piece of tech that you just simply set up, point it at your bucket, and you're off to the races. So that's the step, that's the process. I'm going to show you that in a second, but I wanted to remind you at this point, your purpose of all this is to ensure that whatever you've built, whatever you've designed, so for us, we're setting up unicorn rides, right? We're aligning users, we're making people happy, we're putting smiles on faces, but we've built an application. We want to make sure that that application does what we want and only what we want. Very, very simple, right? Very simple concept, applies globally. We have 3 pillars for serverless security. We've got services, we've got code, we've got data flow. Here is the key slide. This is, you want to take a picture, this is the one, we're tweeting it out after, don't worry. There are 11 steps to do serverless security, okay? I realize there are 12 on here, but step 0 is simply accept the modern definition, right? This is it, very, very simple. You walk through these in order. A lot of them, the beauty is they're manual, right? You do them once, they're an exercise, get the team around the whiteboard, walk through them, have a discussion, understand what you're dealing with, understand the services, understand your data. Very, very straightforward, obviously very low cost. At some point, I hope there will be security tools around serverless that we can do to automate a lot of this, but right now, as you know, with the security designs, we're still talking about it. This track has been phenomenal. The talks within the serverless track here at reInvent, it's cutting edge. We're still all feeling this out, right? We want to know how this works. We haven't determined what our best practices. We haven't determined how to scale a lot of this stuff in different scenarios. Security is the exact same way, especially when, and I hope you understand this a little bit better, it challenges the fundamental assumptions that we have around security. A traditional approach to security is I'm going to build a really strong wall and everything behind this wall is safe, right? And I'm going to tell you no every time you ask me a question. That doesn't work in serverless. Because we're delegating almost everything out to our service provider, there's a lot more trust, there's a lot more inability to influence. We can't install code on AWS Lambda that runs in the core service, right? It's a service to run our code. We can't change the way S3 stores data. Right? We can't add a firewall around S3. We can't add additional things. We need to take and understand what AWS provides and use that to our advantage. Now, the good news is they have given us all the knobs and levers we need. The components are there. You just need to read up on them. You need to understand how to apply them. Walk through these steps. Very simple, very straightforward, but at the end of the day, if you go through this exercise, you will be far more confident in the risk acceptance on your application, on the security posture of your application, and hopefully you'll have a better understanding of why you're doing what you're doing. And then you just simply walk through these anytime you're making substantial changes, right? Because part of this, you're setting up automated checks and balances, but that's it. It's not rocket science. It can be a boring step through. It's a boring trudge through the mud, but it's a required one. Far better to go through these steps and understand what you're dealing with than to end up on the front page because you've made a simple mistake. You know, somebody made an honest mistake and you've exposed all your data unnecessarily. So that's it. It's not rocket science. I thank you very much. I'll be around for questions afterwards. You guys can always hit me up online at MarkNCA. I appreciate you guys taking the time out of your busy day, and I hope you have a great rest of the conference.